Well, individual tetrahedrons and individual octahedrons are not found floating around out there in the mineral portion of the soil by themselves. Rather, the tetrahedrons and the octahedrons are arranged in long repeating units inside of these mineral structures. And they are bonded together through oxygens being shared between two adjacent tetrahedrons or between two adjacent octahedrons in here in the middle of this plane. So we actually don't have as many oxygens included within the mineral structure as one might initially think. In other words, every tetrahedron does not have 4 separate oxygens, and every octahedron does not have 6 separate oxygens or hydroxides. Rather, oxygen are shared between adjacent tetrahedrons in the structure and or between adjacent octahedrons in a structure. So this phenomena of oxygen sharing is helping to hold these mineral structures together into sheets or platelets. So if we look at the individual, the smallest unit of a mineral is either a tetrahedron or an octahedron, but they're going to combine together in long repeating units, which we will call tetrahedral sheets or octahedral sheets. These tetrahedral and octahedral sheets will fit together in platelets. These platelets have 2 basic types of structure. Illustrated on this particular chart is the 2-to-1 type of structure. And by 2-to-1, we're talking about a tetrahedral sheet, an octahedral sheet, and then another tetrahedral sheet forming a basic unit or platelet within the mineral. So the term 2-to-1 comes from the fact that we have 2 tetrahedral sheets with an octahedral sheet in between. So a ratio of 2 tetrahedrals to 1 octahedral within a platelet or layer, as illustrated here, is one of the 2 basic types of mineral structures or platelet structures within the minerals. Now you'll also notice that when we get down here and look at the cations, silicon will be the predominant cation in the tetrahedrons. Aluminum will be the predominant cation in the octahedral layer, although magnesium can also come in here. And then we get down to the bottom again, this would be the other tetrahedral layer. So actually this oxygen right here that I've got my pointer on right now is being shared between not 2 adjacent tetrahedrons, but between a tetrahedron in this bottom layer and an octahedron in this layer up here. Indeed, the degree of oxygen sharing is very, very substantial, not only within a sheet, but between the sheets. Between an octahedral and tetrahedral sheet, we will have shared oxygens as well. These shared oxygens really help to firm up or stabilize that mineral structure. They help to hold it together into this basic platelet. In between one layer of the platelet, which remember is consisting of a tetrahedral, octahedral, tetrahedral sheet, here's another one, another TOT, tetrahedral, octahedral, tetrahedral sheet down here. Well, something has to hold one sheet to the next sheet. And these are most often what are called adsorbed cations. And in some cases, water also gets in there, and the hydrogen oxygen bonds can help hold these together. But these interlayer cations, sometimes they are adsorbed, meaning they're held. They're actually a part of the mineral structure between these layers or platelets. A term that your textbook uses for these is called accessory cations. So accessory cations fit in between one platelet in the mineral structure and the other platelet in the mineral structure, and that is partially responsible for holding one platelet to the next. These are called adsorbed or accessory cations. Most often, these cations are large. They have lower positive charges. They're larger in physical size than our silicon, aluminum, and magnesium. Most often in this interlayer cation position, we find things such as potassium, calcium, and sodium. You'll notice those were the other major cations that were a part of the mineral composition of the soil. So within a platelet, we have shared oxygens. between octahedral and tetrahedral sheets, and then side to side between two tetrahedrons, holding the structure together into a stable type of arrangement. But in between one platelet and the next platelet, fitting in here in this interlayer space, we have accessory cations. The other thing that can fit in there and hold those together are hydrogens. Hydrogens are small, they have only one positive charge, but because they are attracted very strongly to oxygen, hydrogens fitting in here, those are called hydroxy bonds, actually cause this mineral structure to be held together much tighter and have a lower or a less amount of interlayer space. So hydrogens are very, very efficient at holding this structure together, more so than large monovalent cations like potassium and sodium. So hydrogen bonding holds one platelet to the next, and also accessory cations helps to hold one platelet within the mineral structure to another platelet within the mineral structure, and they would both fit right in here in this interlayer space. In addition to accessory cations and or hydrogens, called hydrogen bonds, in there helping hold these platelets together, we can also have oxygen being shared between an octahedron in one layer of the platelet and a tetrahedron in an adjacent layer of the platelet. This particular graphic in front of the screen for you now is illustrating oxygen sharing between adjacent tetrahedral and octahedral sheets. This is the octahedral sheet, represented by this portion of the diagram. The tetrahedral sheet is represented by this portion of the diagram. So you can see that in order for this structure to be fitting together, this hydroxide is actually a portion of the octahedron above. This oxygen is a portion of the tetrahedron down here, but it is also a portion of the octahedron up here. And the same would be true for this. You cannot share only one oxygen between a tetrahedron and an octahedron. You have to repeat that sharing pattern in order to stabilize this structure. In other words, that's a shared oxygen, that's a shared oxygen, then we have a hydroxide that's only a part of the octahedron up here. Then we have two more shared oxygens, this one being shared between this tetrahedron and this octahedral structure up here above. This shared oxygen is also a part of this tetrahedron and this octahedral structure above up here. And then we go back to a hydroxide and so on. Literally thousands of these units would be repeated in a very long chain-like fashion to form one platelet within the mineral structure.